Start now.
Yes. Hi, and welcome to this April 2024 Bitcraze Dev meeting. In this dev meeting, we're going to talk about the Crazyflie Client, past, present, and future. We thought it was a little bit interesting to talk a little bit about the history of the client, since we've been talking more and more about replacing it, or at least improving it quite a lot. So first, let's look at where the client sits in the full Crazyflie ecosystem. So we obviously have the Crazyflie, which is an open source nano drone. We have a bunch of different boards that are compatible with Crazyflie, so bold to make a bigger drone, for example. The Crazyflies can use positioning system. It's usually going to be a receive operation, except for motion capture, but that's one side of it. And the other side then is going to be the PC. And on the PC, you would need a software to communicate with Crazyflie and control it. And that's where what we call the Crazyflie Client exists. Originally, when we started Crazyflie, we started the very, very first Crazyflie in 2009. Back then, there was no drone looking like it. I mean, even the small toys you can get nowadays did not exist. And so we had to invent everything, basically. So we started by having to choose between Python and Ruby. I liked Ruby more than Python because I thought it was more elegant. But already back then, Python seemed like it was going to be the winner for this kind of a use case, at least, and it was. So we chose Python. We wrote the very first client in Pygame because it was an easy way to get a gamepad, because the very first client was directly translating gamepad input into radio packet for the Crazyflie to fly, and on the other way around, getting custom packets that contain roll, pitch, yaw, and other value we wanted to observe, and just showing them into a very simple SDL window. I couldn't find a screenshot of it, unfortunately, but it was something very, very simple. It was connecting as soon as we launched it, and we Control-C to stop it. Then when we started making the Crazyflie for real, we had to do something a little bit more usable, and for ourselves as well. So since the first one was not modular at all, we ended up the other way around, trying to make everything as modular as possible. So CRTP, which is still the communication protocol to the Crazyflie, has a notion of ports. You send packet to a ports, and each port corresponds to an RTOS task in the Crazyflie, roughly speaking. That was the idea, at least. And the idea was to have this very modular, so you could create a new task or a new port very easily, independently of the other. Same thing for the client. It's organizer and tabs, and each tabs are almost like plugins. They are very separated from each other. So it's fairly easy to add a new tab without touching anything in the code. All the connection handling and things like that are handled on the side for you. And features were implemented as needed during development. So for instance, in the co-working space where we were at, there was a mini maker fair organized, and then there was kids, and we had the experience of kids not able to fly the Crazyflie. So we implemented this teacher-student interface where you could connect two gamepad and choose which gamepad handled the thrust, which one handled roll and pitch, and even have the teacher activating or deactivating control from the student. And I think this is still in the client right now, and this is a non-trivial piece of code that no one is ever using. In a similar way, we have a 0MQ interface. So 0MQ is some kind of network socket on steroid. It's a very nice library that allows to have very easily network connectivity between programs. So it's possible to actually have a Python script or any script talking 0MQ act as a gamepad. And this was developed because we were working with autonomous control. So we had a Kinect with a Python script reading the Kinect, so this 3D camera, looking at the Crazyflie, and then another program doing some position control at sending set points to the client, to the normal client, to control the Crazyflie. And that worked for a while. But same thing, it's not very well advertised and not very well used, I think. At this point as well, we implemented generic log and param. That was mainly because first Crazyflies, we implemented manual packets for everything. So which means that each time you wanted a new logged something new, you had to change code everywhere. And that was not very scalable. And that stayed. That's one of the best functionality of the Crazyflie, I think. And we ended up to have about one tab per deck eventually, since it was easy to make tabs and they were independent from each other. There is one tab for the LP, the lighthouse, one tab for the local positioning system, and so on. And also just for the history, originally it was a very custom Python project. By that I mean there was no setup.py. You could just run Python, the Python file, and there was a lot of, we hacked our way around to get it to work. But eventually, after visiting FOSDEM and getting to talk with clever people that knew how to do things in Python, we did make a setup.py, started uploading on PyPy, and now it's on PyPy. You can pip install CF client. And we started working also with trying to make Windows build, Mac build, to make it work without having to install Python manually. For Windows, I think we tried Py2exe, PyInstaller, maybe something else. They all broke one after each other, for our use case at least. I have had multiple failed attempts at making a Mac build. And there was a Ubuntu snap that I need to remove because it has not been updated. Same thing, it just stopped working. So what do we have today? The client is a pretty good way to explore and work with the Crazyflie. We actually like the functionality it has very, very much. It allows to dynamically set and get parameters in the Crazyflie, so you can very easily poke into things and experiment. You can graph log value over time, so there is a very simple but very effective log tab that allows you to choose what variable to log them and even save them in a CSV file for analyzing later. Control the Crazyflie both manually and with simple autonomous behavior. So just take off, up, down, land, left, right. That can be done in the client. Super nice to test positioning systems. And of course, setting up positioning systems and other decks. So we have, like I said, we've made one tab per deck. And if you look at the screenshot I took here, this is from my PC. I just launched the client and took a screenshot of it. I have flight control, console, local positioning, and lighthouse positioning, and that is very typical. Since I have not been developing so much with Crazyflie, but more using it lately, or at least when it comes to the client, those are the tabs I have to set up systems. So this is, the client has been really good for that. It supports connection to a single Crazyflie, and that is because of history. I mean, originally we had a single Crazyflie. There was no idea to make two fly at the same time. Already making one fly was good. And we've evolved from that. And it's also very importantly used to update the Crazyflie firmware. It can connect to the web, get the latest version, and flash your Crazyflie to the latest version. That's a very big functionality. Technically, it is a Python program. We support Python 3.8 and more, hopefully. That might be a bug with 3.8. We will soon drop 3.8, 3.9 anyway. We have had philosophy of supporting the last two Ubuntu LTS. So Ubuntu 22.04 is going to be released in a couple of weeks now, which means that Ubuntu 20.04 is not, 24.04, sorry, it's going to be released in a couple of weeks, which means that we will stop supporting 20.04. And also Python 3.8 anyway is going to be stopped to be supported at the end of the year. So that's something that might happen now. And if this is also a problem, of course, but there's so much we can work on supporting, and that's something we'd like to solve, of course, for the future. We also use PyQt. or Qt. We use PyQt because it seems to be the best for multi-platform support. So, however, it's only distributed for PC and Mac as binary on PyPy. And other platform has to rely on OS packages. So we have had the problem with Raspberry Pi recently because of that. So this is not ideal, and PyQt has caused a lot of problem as well in terms of things stopping working. And when they switch to PyQt 6 and stop to support PyQt 5 for open source user, that's cost us a lot of work to port things. So, but anyway, that's what we use right now, and I think that's pretty well suited to making a PC application. Client and lib. So there's a library on the bottom of the client that actually does the connection to the Crazyflie. Those are distributed on PyPy so that they can be pip installed. And we don't build anything anymore in the sense that we don't build an executable for Windows and we don't build a app for Mac. It never worked anyway. The user have to be to install Python first in order to use a client. So that's kind of a fact. Right now, which is not such a big problem because in robotic, usually people have Python installed, but it is suboptimal, let's say. And yeah, Python, eventually, we choose Python because it was a scripting language, because we thought it would make it easy for people to hack on the client, and because it was multi-platform. It ended up being much, much, much harder than we thought, and it actually makes things very, very hard because everyone has his own version of Python on his own OS, and it means that if there is a problem, the problems tend to happen on the user side and not on our side. So we keep having problems reported that we have to fix after the fact. So that has been very challenging to maintain this client over time. Always have to extinguish fire, it seems. So now we've seen the present, let's see what we would like to improve and what we think, like how we would like to improve things. So portability, like I said, Python makes it very hard to maintain a multi-platform GUI. At least that's what we have experienced, because things keep breaking. It's not helpful for us to have hardware in the loop, actually. Things that breaks are usually things touching the hardware, like gamepad support and things like that, or USB support. And the GUI, I mean, everything. We feel, or at least I feel pretty strongly now, that the compile language will give us more control. I am aware that multi-platform is very hard anyway, but if we had something compiled, at least we would see most of the problem on our side when we compile. We could be much easier to work with. Then we can fix things when we develop. We don't have to come back weeks later, find a bug, try having to come back into it. This makes us lose so much time. Making the client work with rows and swarm would be very nice. This is a use case that did not exist at all when we created the client originally. But the client is a very good interface to experiment and work with Crazyflie. I mean, much better in my point of view than what we have, for example, in ROS. Because it's actually suited for the Crazyflie. It's been developed for the Crazyflie especially. So kind of the dream would be to be able to connect the client to already connected Crazyflie, either with lib or with ROS, and being able to attach to it and talk into the Crazyflie the same way you can attach GDB to an to a process on your computer, this kind of thing. So this would be very, very nice to have, and we've been thinking about doing that for a long time. So hopefully we'll find a way to do it. And finally, web client. That's something that becomes more and more possible because what I mean by web client is having the client working in a web page. Web USB and Web Bluetooth works very well only on Chrome, unfortunately, and Chrome-based and WebKit-based browser, but at least it works really well. And it also would allow us to control the Crazyflie over Wi-Fi decks. We have the AI deck right now that has Wi-Fi, but we might have more Wi-Fi deck coming in the future. So having a client that we can actually, I mean, here, the idea would be that you would connect your Crazyflie over HTTP and client will pop up. And for Web Bluetooth and Web USB, you would have the web page able to access the Crazy Radio or able to scan and connect the Crazyflie over Bluetooth. So those are, and of course, the main advantage here is that we would switch from having to install Python in half of the internet in dependencies to just opening a web page and having a client and being able to work out of the box. So that would be a great improvement for at least very simple use cases. So how do we implement that? First thing first, we want to at least risk up the client functionalities. So rethink a little bit what the client should be, what functionality we should keep, what we should be implemented outside. For example, what one might argue that the firmware update should be somewhere else. Maybe not. If we connect to already connected Crazyflie, maybe the connection is not part of the client, or maybe it's outside part that can be called by the client. We don't know exactly what that means, but since we would like to shake things up a little bit because we think that we are kind of at the end of the road with this client, it might be time to think a little bit about what we want a new client to do and what do we need nowadays in 2024 and for the next years. Of course, there is some Rust. If you followed us and followed me a little bit, that should be part of it. So we've been thinking about implementing Crazyflie in Rust. There is already a prototype existing. We do not want to drop Python. We think Python is, or at least I think Python is still very, very good. Maybe not for distributed multi-platform GUI, but I mean, in robotics, it's used a lot. It's very good for experimentation. It's used by a lot of people. So we would, in that plan, make a Python binding that would have Rust on the bottom. And then the advantage of Rust is that Rust by experience is very, very good for targeting multiple platforms. It basically works compiling Rust on multiple platforms, usually. The toolings are very modern and very well done. And it would allow for WASM, WebAssembly, web support. So we would have one lib that work in Python, work in Rust, multi-platform, and work in the web. And of course, then we could implement the client in Rust on the top. The current idea would be to use Tauri, which is a little bit like Electron. It's like it allows to implement application in a web interface. But compared to Electron, you don't ship a full web browser. You use a web view from the OS, so it's much lighter. And the idea then would be that the web client and the native client would be based on the same thing. Of course, a drawback for me is that it's using HTML, but apparently I'm the only one to prefer Qt to HTML. And a lot of people know HTML, CSS, so that should not be a problem in the grand scheme of things, and might be able to get used to it. And that can be built for Windows, Mac, Linux, Raspberry Pi, etc. And we can build that in our CI. Again, toolings around Rust is very good for that. So this is things I've been experimenting with, and that just works. And when it doesn't, we can just fix it on our side. And it would work out of the box for people. So as soon as we have make an exe or an .app or whatever for any platform and tested it in CI, it should work. There will be no question about what version of Python, what version of different library people have on their own computer. So that's at least that's a plan. And then when it comes to dynamic connection, like connecting an already connected Crazyflie, this is still things that are up in the air. We don't know exactly what to do. Eclipse Zeno might be a good idea. This is a communication protocol that's been designed for robotics that ROS2 is actually discussing about using. So that might be a good, at least, communication layer to have on the bottom. But let's see how this, this is still something that we might want feedback on, at least, also. Yes, so that was it. Is there any question or any comment, or does anyone is against Rust, or is anyone against Rust?
No questions for me.
Oh, okay. But in that
good.
case, yeah, for so for people looking at this on the YouTube, thanks for watching. We're doing this dev meeting every first Wednesday of every month, hopefully. I mean, this one was delayed by 1 week, but come to our GitHub discussions for more information about the next dev meeting. And I will now stop the recording and we'll be able to take question offline. Thank you very much and thanks for watching.
Oh, do I have to? Oh.
Yeah, you have to stop the recording, please.